Morning, class.
Morning, sir.
Morning, sir.
Morning, sir.
The vertical wall of a building stands on a horizontal plane. At A, against the wall, a flagstaff 80 is affixed to the wall such that it forms an angle Z with the horizontal. At B, the angles of elevation of A and D are X and Y, respectively. And BC equals A. We want to prove that 80 equals A sine Y minus X over cos X sine Y plus Z. When solving 2D and 3D problems, we will be using the sine and cos rule. Thus, we will proceed as follows. First, we identify the triangles that contain all the information given to us. Then, we apply our knowledge of trig ratios, the sine rule, and the cos rule. Next, we identify a side that connects these triangles. And finally, we manipulate the problem. Looking at the diagram, we have information in triangle ABC and triangle ABD. The side that connects these two triangles is AB. So our initial aim is to relate information in triangle ABD with information from triangle ABC via side AB. Looking at the problem, there is an angle Y minus X and an angle Y plus Z. Before continuing, we need to ensure that the diagram depicts these angles. The angle of elevation of A from B is X, and the angle of elevation of D from B is Y. Thus, the gray shaded angle is the difference between Y and X, which is Y minus X. In triangle ABD, we have an angle Y minus X and an angle X plus Z. Thus, the angle Y plus Z will be derived from this triangle.
Sorry, Carrie. How did you get that angle X that is adjacent to angle Z?
Tracy, the angle adjacent to Z is alternate to the angle of elevation of A from B, since we have two horizontal lines which are obviously parallel to each other. Thus, we have alternate angles.
Great, thanks, Carrie.
Sure, Tracy. Since the angles in a triangle add up to 180 degrees, it follows that the angle Y minus X plus the angle X plus Z plus angle D equals 180 degrees. Therefore, angle D equals 180 minus Y plus Z. We can now start the problem. Starting in triangle ABC, AC is perpendicular to BC. Thus, we can use trig ratios. We will thus relate the given angle in this triangle, which is X, along with the given side BC, which is A, to side AB, which is our connecting side. Relative to X, BC is the adjacent side, and AB is the hypotenuse, since it is opposite the right angle. The ratio, adjacent over hypotenuse, is cos. Thus, cos X equals BC over AB. BC equals A, so cos X equals A over AB. Thus, AB equals A over cos X. We'll call this equation 1. In triangle ABD, we can relate the angles Y minus X and 180 minus Y plus Z to sides AB and AD by using the sine rule. Thus, AB over sine 180 minus Y plus Z equals 80 over sine Y minus X. Sine 180 minus Y plus Z reduces to sine Y plus Z. So, AB over sine Y plus Z equals 80 over sine Y minus X. Thus AB equals 80 sine Y plus Z all over sine Y minus X. We'll call this equation 2. Now that we have two different expressions for AB, we can put them equal to each other. Thus, 80 sine Y plus Z over sine Y minus X equals A over cos X. And since we want to isolate 80, we multiply both sides by sine Y minus X to get 80 sine y plus z equals a sine y minus x over cos x. And now dividing both sides by sine y plus z, we get 80 equals a sine y minus x over cos x sine y plus z.